just in case it makes a difference. Okay, so I've got basically 2 more examples that I want to go through about related rates. And remember that with related rates, what we're doing is we're taking all the derivatives with respect to time. So let's start with page 256, number 18. And if somebody would read it for us through part A. Reservoir. Okay, so let's redraw our picture here. Here's the reservoir. A reservoir is just a place where you hold stuff. Okay, it's like it comes from the word reserve. So you would, it may very well be a French word. Okay, and so we're going to have the radius, capital R, where capital R is that 13 meters. And remember that that radius is the same as it goes from the center to any part of the bowl. The life lesson we learned in AP Physics yesterday may come to play here. Okay, a little bit. And then there's a certain water level in here at some radius R and some depth Y. And this little r goes from the middle out to the edge. It's the radius of what would be the circle. Because if it's a bowl and I cut a slice through it where the water is, think about looking into a bowl or a cup. You've got a circle of water on the top. Okay? And the radius of that circle of water is little r. All right? So, part A says, at what rate is the water level dropping when the water is 8 meters deep? Zoe, why is the depth of the water? So, in part A, what are we supposed to find? Okay, so now I need to find dy dt, okay? Now, part of understanding the problem is identifying what we need to find, like we did, putting a symbol to it. But we also need to talk about our knowns, the information that we have. So what kind of things do I know? Okay. What else do I know? Okay, the radius of the whole reservoir, capital R, is 13 meters. What else? What rate of change, Zoe? What? dV dt. And dV dt is what? Per second? Per minute. Okay, but let's talk about that for a minute. What's happening? Am I adding liquid to my reservoir, or am I taking liquid from my reservoir? It says that the water is flowing out, so I'm losing it. So it's got to be a negative sign there. Okay. So I know all those things, including the rate at which the volume is changing, and I need to find the rate at which the height is changing. So what am I going to do? What's my next step? Okay, so I need to find an equation. That's really the next step. I need to find an equation that relates the thing that I'm looking for with the things that I have. Now, the way this usually works, especially in calculus, is I find the equation and then I take the derivative. And that's where the dv dt and the dy dt are going to come in. So what I'm really looking for at this point is an equation that's going to have v and y in it. And what's that going to be? Okay, so there's my equation. And then since I want to talk about the rates, I want to take the derivative. Is anything up there going to be constant? Okay, so the pi over 3 is going to be a constant, and the capital R is going to be a constant. But when I look at this, I've got y's in a couple of different places. So what do you want to do either when we take the derivative or before we take the derivative? I could multiply through, I could distribute. It's not technically FOIL because I don't have two full expressions inside, but we could just rewrite this. I'm going to leave my pi over 3 out here, and then I get 3r y squared minus what? Y cubed. And now it might be a little easier to take the derivative. I could have done the product rule too. Okay. So remember, we're taking the derivative of everything with respect to time because that's what related rates have to do with. So I can just leave my pi over 3 out here. And what's the derivative of 3ry squared going to be? 6ry. Maggie, what's the derivative of y cubed going to be? Okay. And what am I missing here? Yep, there should be a dy dt after each of those terms, so I'm just going to factor it out. Okay, because remember, when we're talking about taking all these derivatives with respect to time, it's really like using the chain rule one more time. So what am I trying to solve for? Dy dt. So really, because everything over here is going to be a number, I can really just solve for dy dt and make it dv dt all over pi over 3, 6ry minus 3y squared, right? And now you do the calculating and tell me what dy dt is going to be. Well, what's the worst thing that's going to happen for you? Okay, what happened to this? And then what are the units? What should the units be? All right, let's see what other people got. Okay, so we got the same thing. Sarah got the same thing. Zoe got the same thing. Okay, so note that it's negative. Should it be negative? Yeah, why? It's a negative rate. And remember that the water level is going down. So if y represents the depth of the water and the water level is getting lower and lower and lower, y should be getting smaller and smaller and smaller. Okay. All right, we good? Okay, how about part B? What does part B ask us for? Somebody read it, please, I guess. Okay. So, I'm not going to draw, well, I could draw my whole picture. So there's my basin again. Here's my level of the water. All right. And then remember that this distance is capital R, and this distance is capital R, right? And in fact, I'm going to erase that capital R a little bit and put it over here. Okay. This is going to be y, and then this distance over here is going to be little r. And little r is what I'm supposed to find when y is this. Anybody have any ideas? Okay, we don't have any equations with little r in it, so we're probably going to have to make something up ourselves. Remember that the distance from the center to the edge is capital R. Priya. Where? I don't see a triangle. Where the, okay. So yeah, there's a triangle. Yeah, well, we have capital R. This is what we're looking for, but if I'm doing Pythagorean theorem, I need a third side, right? Excellent, Priya, way to go. Yep, capital R minus Y. Similar a little bit to what we were talking about in physics yesterday with the pendulum and the position that the pendulum was. Okay. So it's a right triangle. My hypotenuse is capital R. And then my sides are little r and big R minus Y. No, because remember we talked about how you don't want to plug in the numbers too soon when you're doing a problem this way. And because really the only number you could plug in would be capital R, because the question specifically says what is little r when the water is y meters deep. Yeah. Okay. So I think the best thing at this point would just be to solve it for little r, but keep everything as a variable. So r squared is going to be big R squared minus r minus y squared. My spidey senses tell me that somehow if I FOIL this out, my capital R squareds are going to go away, right? So r squared minus r squared plus, I'm going to, plus 2ry minus y squared, actually. Well, because this negative y is going to get squared and be positive y, and then I've got my negative sign from the outside. And like I suspected those y squareds are going to go away, or I'm sorry, those r squareds are going to go away. And then yes, as Priya suggested, I'm going to take the square root of 2ry minus y squared. I was just going to ask that question. Should I put a plus or minus sign in front of it? What do you think the answer is? Why not? Right, the radius can't be negative. This is a physical measurement in space. It's a magnitude, okay? It's not like we're talking about whether it's east or west or north or south, and I may have put an arbitrary negative sign on it. It's just a measurement, a reading off of a ruler. Okay? All right, so we're going to keep that and remember it. And then what does part C ask us to do? Or read us part C, someone, please. Okay, so what are we supposed to find? dr dt. And I need to, if I really understand the problem, then I can also make a list of things that I know, like what? Okay, so dv dt is what, minus 6 meters cubed per minute. What else do I know? I know what y is going to be. What is it going to be, Maggie? 8 meters. There's one more thing that I know. Oh, I know capital R, 13 meters. All right, there's one more thing that I know. I don't actually know what little r is. I could figure it out, but that's not in my knowns. There is another, my knowns are going to be like my numerical values. Again, my knowns are organizing the numbers that I know. The numbers and what symbols they go with. And there's one more number that's not up there. dy dt, good. And dy dt was what? Negative 0.013, good. Meters per minute. Okay, so now I need some kind of equation that relates r with other things so that I can take the derivative of both sides. It could have capital V in it. I don't think it will. But I know two rates. I know this dy dt and I know dv dt. So as long as I get one, either v or y, I can use that rate when I find out the rate at which r changes. But what's the equation that I can use? Yes, we could just use the equation we found. In fact, that's why they asked you to find it. So r is equal to the square root of, what is it, 2 minus y squared. Okay. So I'm going to rewrite this as 2ry minus y squared to the 1/2 because I think it's easier to manipulate when we take the derivative. And then we're going to take the derivative. So we're going to have dy dt. And how do I take the derivative of this side? Okay, so I start with, oops, hang on, to to the negative 1/2. And then Sarah Hamden, what's the derivative of what's inside? Let's take it term by term. What's the derivative of 2ry going to be? No, because r is going to be a constant. So it's going to be 2r, and the derivative of y is 1. Hang on. I could put in my dy dt, yes. And then, Sarah, I've got y squared, so what's the derivative of that going to be? You got it. Okay. And then I am sure there is some algebra and some simplification and whatever, but I'm just going to substitute in numbers. So let's just substitute in numbers. And you tell me what you get. And be careful with your negative signs there. Is she right? Yeah. That's what I got too. What should the units be, Gianni? Good.